Hello, today we are going to talk about the history of the Linux kernel and the history of the BSD operating systems for the Intel 386 CPU. Which of these came first? What would have happened if the lawsuit against BSDi did not happen, etc. It all starts with this Reddit thread where it asks theoretical questions like what would be the size of the BSD operating systems if the Linux kernel and the Linux distributions did not exist. Would we have hardware that's user-centric and that uses the BSD, one of the BSD kernels instead of the Linux kernel, such as the Steam Deck, such as the Android phones, such as the Chrome OS laptops and tablets? So let's look at the 386 BSD, which is the operating system from Bill Jolitz, and how this then became the NetBSD, FreeBSD, and then the OpenBSD operating systems. Around which years did these changes happen? When did the Linux kernel start? So let's start actually with the Berkeley, University of California, Berkeley distribution version net/2. Okay, so this is at the time of the Unix style operating system from University of California, Berkeley 4.3 BSD, which appeared in 1986. Had very strong support for a TCP/IP networking stack, and in general for internet servers such as the Usenet servers and email servers. In 1990, the version that came out from CSRG, the group at UC Berkeley that created the BSD operating system, was 4.3 BSD minus Reno. And then across the time, because the BSD operating system was encumbered, if you wanted to run BSD from CSRG legally, you needed to have a license from the holders of the Unix operating system, such as AT&T or the Unix group, Unix System Laboratories. There was an effort at UC Berkeley to rewrite all of the encumbered source code files from scratch such that you can use BSD as a full operating system without needing files from the Unix source code and without needing licenses, a license from the Unix holders, from the vendors of Unix. Network release 1, net/1, was made available to non-licensees of AT&T code, was freely redistributable. Was released in 89. Keith Bostich they made a review after net/1 which of the executables and the source code files still relied on source code from USL, and they rewrote most of it, including VI, and the resulting release was net/2, networking release 2 from June 1991. Let's actually put this thing on a timeline. Okay, so June 1991 net/2. There's no need to go down in history older than this moment in the history of the BSD kernels and the BSD operating systems. Okay, and then from net/2 there were two independent ports to the hardware of the moment. So we're talking about the year 1991. The hardware of the moment was the Intel 80386. Which was better than what people had at the time, which is IBM PC compatible 286. And additionally, it had the extra protections in hardware compared to 286. So more modes. The protected mode appeared in 286. So these two efforts are an open source one, 386BSD by Bill Jolitz. So this was free in the sense of no cost. And then there was BSD 386 or BSD OS from BSDi. So this is a commercial operating system from the company BSDi, which was created in 1991 by members of CSRG. So CSRG is the group at UC Berkeley that has created the BSD operating systems, the BSD releases from CSRG, including net/2 and BSD 4.3, BSD 4.4. It makes sense that the people that were part of CSRG create their own company and try to sell the software that they worked on, which is net/2. Okay, let's look a bit at 386BSD. So BSD/OS was part of the litigation from USL versus BSDi. Let's look at the timeline of this thing. So this was April 1992, and then the settlement out of court happened in 1994. Let's see which month of 1994 because it's important. So how it ended is that USL was part of AT&T in July 1993, in the middle of the lawsuit. USL was bought by Novell with two L's, and Novell tried to settle the lawsuit. Let me find out the exact date. So probably the settlement out of court was February 1994. There was a countersuit by Regents of University of California, Berkeley, in 1993 against USL because a System V used a ton of BSD code and probably did not respect the license. The software license was probably, I don't know, BSD with 4 clauses, and that requires a ton of advertising. Okay, and the end result was that net/2 was questionable for a number of years. Requested a preliminary injunction on the distribution of net/2 both from BSDi and University of California. So net/2 wasn't really redistributable in this period, April 1992 to February 1994. Let's look a bit at the release announcement of this net/2 operating system release. So it came from Keith Bostich, and the date was July 1991. It says that it's not, how do we zoom this thing? Says that it's not a full operating system. Much of the kernel includes 75% of what makes up 4.3 BSD Reno from 1990, the C library, much of the kernel, and then it says that significant portions of the kernel are missing. There are no binary releases, binary artifacts for this source code release, and that you must have the 4.3 BSD Reno operating system release installed in order to compile the source code for net/2 and then to run it. And then from you also need some files in order to be able to compile the kernel from 4.3 BSD -Reno, because they are missing inside of the kernel of net/2. It's meant to showcase the most recent BSD system from Berkeley. Not intended for production, and it's going to be sold on tape. Okay, we can see that it was made by CSRG, Computer Science Division, University of California, Berkeley. And this is probably the most important part of the team that worked on net/2. So Keith Bostich and 4 more people, including Kirk McCusick. Okay, back to the Reddit article. People think that somehow Linus Torvalds had access to net/2, or that Linus Torvalds installed net/2 somewhere, maybe on his home computer or maybe at the university where Linus was a student at that time. But then back, if we look at the release notes of net/2, it says that the distribution is 90 megabytes. So this is probably byte, not bit. So let's note here that this is 90 megabytes in size. So it's probably, I know, a tarball 90 megabytes in size, which Linus Torvalds did not have 90 megabytes on his home computer, the only computer where he developed the Linux kernel for a large number of months. It was his personal 386 computer, desktop computer, and it only had 40 megabytes of IDE hard disk. Let's go back to the article on net/2. It ends with 2 quotes, and the text is like this. 386 BSD, which is the free operating system from Bill Jolitz and his wife, was released in 1992. Bill Jolitz worked for a number of years on 386 BSD. It says from 1989. Let's write this down. So 386 BSD. Bill Jolitz. 1989, and Bill Jolitz was part of CSRG. Both him and his wife were part of CSRG, University of California, Berkeley Computer Systems Research Group, when they started porting to 386 in 1989. And then they stopped working on 386 BSD in 1994. This is the moment, late 1994. So late 1994, the final release 1.0, so it took 6 years to get to 386 BSD release 1.0, widely distributed with Dr. Dobb's journal, CD-ROM, 600 megabytes. So this was in a time that people didn't really have CD-ROM drives in 1994. The size was extremely large for the hard disks of the time, 600 megabytes. Meanwhile, between 1989 and 1994, the Linux kernel did appear, the Linux distributions did appear. Linux was past its 1.0 release. It could run the networking bits from net/2, so the networking executables, the ping, the telnet, the server parts, it had a TCP/IP stack, it had X3, so an X server, it had Wine, a ton of things were available for existing Linux distributions by late 1994. Okay, let's also note down the releases for 386 BSD. So version 0.0 March 1992. Then version 0.1 July 1992. And the fact that it was featured in Dr. Dobb's journal. So there was a series of articles in Dr. Dobb's journal that Linus Torvalds was up to date with. So Linus Torvalds did read the Dr. Dobb's journal issues that were talking about 386 BSD. Probably more than in this period. Maybe also outside the period May-June 1992, there were articles about Bill Jolitz's 386 BSD in Dr. Dobb's journal. Okay, next up, very interesting comments in the Reddit thread, including the comments from BSD imp that says Warner, so it's signed Warner, and says that this person was part of the first days of the FreeBSD operating system. There were patch kits to 386 BSD. Let's also note these downs. So because of the 386 BSD did not have, releases every couple of months, the enthusiasts and the people around the internet that were wanting to contribute to 386 BSD, were wanting to distribute 386 BSD, were wanting to port software to 386 BSD, diverged. So they had different implementations because the upstream 386 BSD did not provide recent enough snapshots of the source code tree of Bill Jolitz frequently enough. It's being said that Bill Jolitz was a perfectionist, and in this case, perfect was the enemy of good. And he didn't release early, release often. FreeBSD was focusing on 386 architecture. NetBSD was focusing on being portable to a ton of CPU architectures. During the lawsuit, 386 upstream continued to get changes by Bill Jolitz, and also the FreeBSD and NetBSD did split out of the 386 enthusiast users and developers community, and says that FreeBSD 1.2 FreeBSD 2 was the release that did not contain encumbered by the holders of Unix at the end of 1994. FreeBSD 1.1.5.1 was the last allowed to contain encumbered code. Let's actually read these comments. So yes, the lawsuit screwed things. Linux was good enough at the time to fill the vacuum, but also part of the buzz was the GPL license and the religious fervor of taking over the world, the revolution. BSD had that, but the GPL was a multiplier in early days, so a ton of evangelization, a ton of promotion. People were helping other people install Linux, whereas the same thing did not really happen for the BSD operating systems. A lot of companies building from the 386 common base, but then did not provide source code back. And also to the FreeBSD and NetBSD open source projects. FreeBSD 1.2 probably could not be released because of the lawsuit. It's hard to know how the industry would have shaken out without a Linus to shepherd some of the early politics. A ton of politics in between, so inside the FreeBSD community, because they don't have a benevolent dictator for life, such as Linus Torvalds. The same thing in the NetBSD community, and then the fact that OpenBSD needed to split because OpenBSD actually does have a benevolent dictator for life and it's not a government by committee such as Debian, NetBSD, and FreeBSD are. The point was that the Linux kernel was already good at the time. Linus did not invent the Linux kernel because of the lawsuit. Linus Torvalds implemented Linux just for fun, and Linus Torvalds also wrote a book titled Just for Fun. So there was this jump from FreeBSD 1.1.5.1 until FreeBSD 2.0, which was a giant effort to make sure that the encumbered pieces, the source code, the files written or which have a bit of copyright by the Unix holders were removed from everywhere, from the BSD, from CSRG, from net/2, from FreeBSD, from NetBSD, from OpenBSD, from everywhere. FreeBSD 1.2 would have been the next release if the lawsuit would not have started. There were patch kits to 386 BSD. Some of these patch kits also existed because Linux was available. Linux was 386 for a long time. FreeBSD only focusing on 386 likely would have filled an analogous role. 386 BSD's political problems doomed it. It was hard to say whether or not NetBSD could have attracted the mindset, or if efforts to port FreeBSD to Spark would have had the same effects that the early ports had in the Linux world. So the Linux kernel is still just one upstream, just one kernel, and it runs on Spark, it runs on 386 runs on AMD 64, ARM 64, etc. on a ton of architecture, CPU architectures. BSD was better set up to be portable than Linux. BSD came to 386 via the 386 BSD effort, whereas Linux started on 386 and it needed to be spike-like. You need to have as many features as possible in as limited time period as possible, so that meant writing the simplest, most straightforward source code possible. That meant not using microkernels, meant using the 386 feature set and the 386 instruction set architecture as thoroughly as possible. But there were a lot of politics within BSD that made it hard to say. So BSD in here is not inside Berkeley, is meant inside the 386 BSD project, NetBSD, FreeBSD. That made it hard to say whether or not infighting could have been fixed or not at one of the splits gained popularity. And a lot of the FreeBSD development was definitely a race against Linux having the same features or performing better at some tasks. The competition helped both in this timeline. I don't see a similar dynamic between NetBSD, FreeBSD happening in the early days. The NetBSD OpenBSD split is better understood, of course. You can read the wiki page for OpenBSD. Then the split from 386 BSD, the patchkits, and the NetBSD, FreeBSD. So Warner joined FreeBSD just after FreeBSD started. So from the split from 386 BSD patchkits to the FreeBSD project, says, I don't know the patchkit part of the timeline in detail. I helped a friend download 386 BSD when Jolitz released it. Which ones? Probably ones from July 1992. Let's actually see the timeline for FreeBSD. In here, the history is not perfect. So it says that in 1992, several months after the release of net/2, Bill Jolitz wrote replacements for the 6 AT&T files that were missing, which were part of the net/2 BSD kernel, and ported BSD to Intel 386, whereas porting was an effort that was started in 1989, so it was 4 years old at this point. Called their operating system 386 BSD, so it says 1992 after this June 1991 release of net/2. The development of 386 BSD was slow. A group of 386 BSD users, including John Hubbard, decided to branch out on their own so that they could keep the operating system up to date. They chose the name in June 1993. The first release. The FreeBSD project has the release announcements for really old releases of FreeBSD, so we're probably going to be able to get at this release announcement. The original. I searched on the internet for FreeBSD release announcement. I get to the FreeBSD 1.0 announcement, which happened in the 1st of November 1993. So probably this one we're talking about. So JHK, JKH. No more Greek letters. So they had releases before these ones, epsilon, Greek letters. The FreeBSD 1.0 release, source code release, is still available on ftp-archive.freebsd.org. We can see the software that was available at that time. So K shell, the X server, X lock, Z shell, TK, wow, TK, TCL TK, text, GNU screen, probably this one. A ton of GNU packages, Deja GNU, Emacs, GCC1, GTP, GhostScript, GhostView, GMake, compression libraries, InfoZip, Perl, incredible list of packages on zip. The X server was already X386. You install the system from floppies, boot and root probably floppies. And check this out, Linux sound driver for the audio card Gravis Ultrasound, Sound Blaster, etc. So it was already using source code from either the Linux kernel or from the Linux operating system, the Linux distributions, to provide features in FreeBSD 1.0, including in the ports collection of FreeBSD 1.0. Let's continue a bit with Warner's comments here in the Reddit FreeBSD thread. So it said that did not have hardware until a year or two later, so probably helped with the FreeBSD project, but using hardware from, I don't know, friends or the university or from the day job. Read a ton of commit messages, Usenet messages. Was not able to reconstruct the patchkits to 386 BSD. A plethora of patches and dysfunction by Jolitz before the patchkits even started up. They didn't last that long before they were tossed into CVS repo, so this is a version control system, on the same machine in Berkeley. So even before the patchkits appeared, there were CVS repos in Berkeley on the same machine of Jolitz. Jolitz did not take those patches and release a new version of 386 BSD. It was clear that NetBSD would focus on portability, FreeBSD would focus on x86. These two could not get along. This function persisted through the early years of both projects. They diverged a lot in the first days of the NetBSD and FreeBSD project. Some of the divergence should not have existed. It's artificial. It's not for technical reasons. Okay, back to the net/2 wiki page. Says that Linus Torvalds had said that if 386BSD or the GNU, in the sense of the GNU herd kernel, had been available at the time when he started, which is March 1991, he probably would not have created Linux. That's very doubtful. Let's actually read what Linus Torvalds says. So this is the history. The person, Linus Torvalds from Finland, is admitted to the University of Helsinki as a computer science student, so that's informatics. Took his first course on the C programming language and Unix at the fall of 1990, so that's September or August 1990. In the spring of 1991, Linus Torvalds had a computer at home on his new 386 computer. And what does Linus install on his computer? He installs Minix. So Linus is probably using the computers at the university to read Usenet, so Network News Protocol. It's Linus is reading the Minix hierarchy on Usenet, is downloading a Minix archive, or maybe the people in university already have it because there's a Unix and C programming language course at the university, and the university probably has a ton of 286 computers where Minix can probably run. So he takes a copy of the Minix source code, probably, 3 floppy disks or something, home, installs on his brand new 386 computer Minix. So this is the spring of 1991. So Linus starts writing things for his university, starts with a hello world program, goes to a terminal program, and in the summer of 1991, he has a protected mode operating system. In October 1991, there's the public release Linux 0.02, so let's ignore the first 0. So release Linux 0.2 announcement on Usenet. Let's actually write these things down. So let's say September 1990. Linus Torvalds, student at University of Helsinki. Unix and C. Okay. Spring 1991 Linus has his own 386 PC desktop computer, installs Minix, which is an operating system. Minix, the operating system, is popular in universities because it's used as teaching material. It's accompanied by books written by the principal developer of Minix. So it's used as material for teaching the class of Unix and C programming language. Okay, so spring 1991 Linus installs Minix, and then on top of this installation, so the 386 desktop computer has 40 gigabytes of IDE disk. Inside, Minix OS creates various C programming language sample applications. And then he starts writing the needed software for a Usenet client. So for reading network news, he writes an NMTP client, a terminal emulator, ncurses, like things, a text user interface, frameworks and applications, networking client, TCP/IP client, TCP/IP stack, all of those things. And then starts with writing the simplest operating system that uses the features of the instruction set architecture for Intel 386 as much as possible. So it uses protected mode. It can boot on his own personal desktop computer. Okay, summer 1991, the Linux operating system and kernel. Maybe not Linux. Okay. And then October 1991, Linux 02 was announced. Let's look at the announcement. Well, there's even more history sources for the Linux kernel. So there's an article written in July 1992 by Linus. There's posts on Usenet. So again, he uses the hierarchy comp.os.minix because he's writing software and he's using the Minix operating system. Helsinki.fi. In the beginning, he used this name, Linus Benedict Torvalds. Netlanders. So this is July 1991. GCC 1.40 for Minix. So the GNU software has strived to be as portable as possible. The GNU AutoTools, AutoMake, M4, AutoConf, AutoReconf, GNU Make, the GNU toolchain had as a very important design goal to be portable to as many operating systems as possible. So software that uses the GNU toolchain can be as easily as possible portable to a ton of POSIX compliant operating systems, but also to non-POSIX compliant operating systems. There's a ton of support for operating systems that are really old, that maybe are very little known even back in the day, but certainly today, such as DJ, GPP for DOS, the Novell NetWare, various variants of Windows, various commercial Unix operating systems, the big ones, Irix, the Sun OS Solaris, the Next OS, the Mac OS X operating systems, Linux, BSDs, etc., etc., etc. So probably GCC was already available for Minix. What are the POSIX rules in relation to GCC 1.40? The project was the kernel, Linux kernel. So by July 3rd, Linus Torvalds was already thinking about user applications. Some of the device drivers for the Linux kernel were already ready, and the hard disk driver was working, nothing else. Wow. Let's write this down. So July, 3rd July 1991, the following exist. Linux kernel can boot and run on Linus's x86 computer. So does this version of Linux run GCC? Can it compile things for GCC? Nope, it cannot. So probably Linux is dual booting, maybe, I don't know, using a floppy disk. So it boots into Minix, edits source code, compiles using GCC, and then the resulting build artifacts, the binaries, are being copied to boot root floppy disks, and then Linus Torvalds is entering the boot Linux floppy disk, rebooting the computer. After that, is swapping the floppy disk with a boot floppy disk with a root floppy disk, and we're inside Linux, not touching the hard disk at all, just running from the second floppy disk. And in kernel mode, in protected mode 386, there's the Linux kernel plus IDE drivers and some device drivers. So some device drivers, meaning you want to see something on the monitor, so you at least have the BIOS support for the interrupts for putting characters on the monitor. Text user interface, the monitor. And yeah, also keyboard, right? So keyboard driver, monitor driver, hard disk driver, and booting from floppies, and the Linux kernel in July 1991, which is almost a year before the lawsuit April 1992 even started, and the lawsuit didn't make any difference for the FreeBSD operating system, because FreeBSD 1.0 was released in June 1993. So the FreeBSD and the 386 BSD community didn't feel any pressure from the lawsuit by the summer of 1993. And the summer of 1993 is really far away in the Linux timeline, because in July 1991 the Linux kernel was already almost, yeah, it could boot on Linus Torvalds' computer. Just the success report on porting GCC 1.4 to Minix using the GCC 1.3 version made by Alan W. Black and the others. Okay, next email. 1 month, 2 months away. So July 3rd, 25th August. So this is to the same usenet newsgroup comp.os.minix. What would you like to see most in Minix? So this is, the title is kind of like Linus will be the BDFL of benevolent dictator for life for Minix. But then Minix is a trademark of Tannenbaum, and this cannot be really done. Somebody to fork Minix and keep calling that thing Minix. But still, Linus needs to start his project, so it's piggybacking the newsgroup comp.os.minix for a while in order to bootstrap Linux, the kernel and operating system. Small poll for my new operating system. I'm doing a free operating system, just a hobby, won't be big as professional like the GNU project. For 386. Has been brewing since April and is starting to get ready. What things do people like or dislike in the Minix operating system? Because my Linux operating system resembles Minix, it uses the same file system as Minix. The Minix file system, it uses the same partitions as file system, the same partition table. Bash and GCC 1.4 has been ported to Linux. So this is a totally different state right now in 25th August 91. So there's the Linux kernel and OS. Linus is booting from the floppy disks, but it's actually running the second root. So actually running slash from, I don't know, maybe it's cherooting or something, from the disk, from the integrated, from the IDE, the PATA disk. OS, again, IDE drivers, input-output drivers, has bash 1.08 and GCC 1.40. So by this moment, it means that Linus doesn't really need to reboot into Minix at all, because he can stay for hours in the Linux operating system. Again, it's running from the hard disk, from the spinning hard disk. There's a bash, which is the Unix integrated development environment. There's Unix, Minix executables. He probably could copy over Minix executables into the Linux operating systems, and those executables just work. I know cat and ls and dir and those things. Make dir, rmdir. So with bash and with GCC and with some text editor probably. And maybe even, I'm going to guess that the integrated development environment doesn't really have two sets of partitions, one for Minix and the other one for Linux. It's just clean from scratch installation of Minix with the Minix standard layout and partitions and partition table on the integrated development environment on the IDE disk. And then Linus just boots from a floppy disks into Linux, but then it reuses the exact same partitions, the exact same directories, the exact same files that exist on the Minix hard disk. So Linus only has one place where he keeps his source code, and maybe just one set of binaries. Maybe Linus can use the same GCC 1.40 when booted into the Linux operating system, or when booted into the Minix operating system, and maybe the resulting, a.out binary files run perfectly on both operating systems. So quite a story of bootstrapping a new operating system from an existing operating system by reusing the same on-disk structures, the same hard disk partitions, directories, files, file layout, etc. The same source code files and the same binary files, in the sense of user space, not kernel space executables, which are probably linked statically. I'll get to something practical within a few months. So I'm just going to guess that there's also an editor in here. So micro Emacs. So by August 1991, there's micro Emacs there. I'd like to know what features to concentrate on next. So totally, if Linus bootstraps the Linux operating system from Minix, he's doing a spike. So he needs to be able to stay inside Linux, not inside the Minix operating system, as much as possible. So the minimum for that is what we see here, the possibility of interacting with the mouse, keyboard, whatever. There's no need for mouse. So keyboard, monitor, hard disk, random access memory, and the CPU, motherboard. The computer boots. There's a file system layout. We have the bash shell. I know probably the kernel boots into PID1, which is written in 20 lines of code, and immediately just spawns bash as the PID2 probably. And then from bash, you can immediately navigate the hard disk. There's the / unified Unix style file system hierarchy. You can go to the correct directory where the source code files are. You have micro Emacs. You open the source code files, you edit a bit, and then you run a bash script to build software from scratch. So maybe there's no GNU make and make files at this point, but if there's bash and GCC, and Linus is using all of the possible features of the 386 instruction set architecture, using all of the possible features of GCC 1.4, all the possible features of bash 1.08, all of the bashisms possible, all of the GCCism possible, such that he has the most features available at his disposal, such that he can write the simplest, cleanest, most readable source code for his operating system. And from that point, once you have this spike, you need to know what do people vote that you should implement next, because maybe it's not useful for you, but it's useful for many people. And by actually implementing something that's useful for many people, not useful for you, you're actually stressing the design of the system, the kernel, the way you port this software, the way you're running layout executables, the file system layout, etc., such that your design improves over time. Doesn't contain any Minix code. It has a multi-threaded file system, whereas Minix doesn't really have a multi-threaded file system. There's all sorts of hacks there. And the main person behind Minix also talks badly about multi-threaded file systems. A bit down in here, so a multi-threaded file system is only a performance hack, says Andy Tannenbaum, the professor. When there is only one active job, so there's no multiprocessing, cooperative multiprocessing, or real multiprocessing, the normal case of a small PC, it buys you nothing and adds complexity to the code. So preemptive multitasking is not that great on 386 computers. On machines fast enough to support multiple users, you probably have enough random access memory buffer cache to ensure a hit cache hit rate, in which case multi-threading also buys you nothing. It is only a win when there are multiple processes actually doing real disk input-output. Whether it is worth making the system more complicated for this case is at least debatable. So Andy Tannenbaum is looking at the problem from the angle of Minix should stay as short as possible because it's reading material for computer science students. Whereas Linus Torvalds is looking from another perspective. He's looking at, I have some toys at my disposal. I have the 386 PC with just 40 gigabytes of storage. I have this great source code bash 1.0.8 that actually runs on my operating system. I have this great software GCC 1.4 which knows the C programming language and works correctly on my operating system and can create executables for my operating system. and I'm going to improve my operating system, make it as performant as possible, make it multi-threaded, make it as long as the overall architecture doesn't get really bad. I'm going to add features and performance, and I'm going to take all of the help possible from either the hardware that I have at my disposal, either the GNU project, or other random people on the internet. So September 91, release of 0.1. So Linux in the sense of an operating system, not just the kernel. There's a bit of userland, there's source code to boot this thing. Okay, so the thread continues, it's pretty large, so the Linux operating system was already announced. I'm doing a free operating system, just a hobby, won't be big and professional like GNU for 38680 clones. And people are immediately interested. Jirki Kopala. Does it need an MMU? It needs an MMU and it needs 386. So we'll not go lower than 386 with MMU, but it works without a floating point unit. Most people won't call what I write C. Some people would look at the Linus Torvalds source code, even it's written in C, would say that it's 386 assembly. It uses every conceivable feature of the 386 ISA that I could find. It's a project to teach me everything there is to know about 386. Uses an MMU. For paging, there's no swap yet, and segmentation. It uses segmentation, really 386 dependent. Anybody who needs more than 64 megabytes or bits per task, not gonna happen. Uses every feature of GCC I could find. The ASM directive. So it uses C source code instead of AS assembly source code. It's still the assembler programming language, but it's inside files with extensions .c. The memory management.c file is 50% ASM and the rest C. But then because the source code is brief and human readable, other people tried to port the Linux kernel, so the kernel land, the kernel space to the Motorola 68K, and they succeeded. And then that was the strategy of Linus. Let's have let me write 386 only a ton of assembly, but really short and performant code. And then other people should take the Linux kernel as it is and port it to other architectures. And then we'll see what needs to be changed in the upstream Linux kernel such that porting to other architectures is way easier than just rewriting a ton of 386 assembly by hand. It uses 386 interrupts, a porter's nightmare. So by August 1991, there's system calls capable of supporting the standard POSIX.1, long file names, not just 8.3. Oh, these are the requested features. Yeah, the requested features. Okay. BSD sockets in the sense of TCP/IP stack from something very similar to net/2. User mode file systems. Linus cannot implement the POSIX standards because Linus keeps asking for the POSIX standard and cannot get it without actually paying. First, I'll make it a simple Minix lookalike simple. Yes, I can run GCC and bash, and most of the GNU utilities, wow, binutils, fileutils. The C library is very minimal, doesn't support floppy disks, no need for that. It has less features than Minix. It will be free, already thinks about using the GNU license. The Linux operating system is using a ton of GNU source code, and it makes sense to also use a similar license for the Linux kernel to Linus. So probably you cannot use Linux to build GCC. It was built on Minix, cross-built. October 5th. (1991) Linux 02 release. And at this point, we will switch to another front entirely, which is the Linux distributions. The first Linux operating system that has almost nothing to do with Linus Torvalds, has been widely disseminated and used by people, and that's SLS. We get to that by going to slackware.uk. So Slackware is a Linux operating system. There's this mirror, slackware.uk. And in here we can see the SLS, soft landing Linux system, Linux operating system. So the first Linux distribution. We have two directories in here, two versions, 1.05 and 1.03. We're going to look at 1.05 and look at the changelog. The changelog. We already can recognize a Linux distribution. It's very similar to the Slackware file system. When you're looking at a Slackware mirror, what you see in here, it's already familiar. When you look at the mirror for the FreeBSD 1.0 release, it's also already familiar. Let's look at the changelog. So the changelog is alphabetic, and this is older and this is newer. So alphabetic, ascending. Let's see what it says in here. So let's go to the SLS. Soft landing Linux system. We can see the first release of soft landing Linux system on 1992 September. So in September 1991, Linus Torvalds released Linux 01, which was made public. Probably on the FTP site, FTP server from the University of Helsinki in Finland. And then less than 1 year later, in September 1992, we already have a first Linux distribution. So a entity totally different from Linus Torvalds. Linus Torvalds was doing his own things upstream in Finland. He was active on Usenet. He was sending, receiving mail. He was using the servers from his university to host the upstream source code release files. And then somebody took the upstream files, took more files, more source code projects from the GNU project, from the X projects, etc., combining them together and creating what you see here, this directory structure. There's A, B, C, X, and then some top-level files, and then some tar gzip files. The entry points are the floppy disks. There's the floppy disk for root and boot, which I'm not sure which they are. They should be 1.4 in size. And here they are. A1.3 and A1.5. I don't see any other files which are 1.4 in size in here. Okay. You took these two files, wrote them to two different floppy disks, and then booted from the first, and then at some point the first floppy disk, while it's booting, it says please eject the current floppy disk, place the second disk. The first one is generally the one that you boot from, so the boot floppy disk, and the second one is the one that hosts the slash, so the root file system, which is the root floppy disk. And from there you can switch to you can install the rest of the operating system again from floppy disks, and once into your spinning hard disk. Once installation to hard disk is done, you don't even need a bootloader. You can just boot from the first disk, from the boot disk, and then from there you can switch. You can select to not provide the root disk, not install the operating system to disk, but use an already installed operating system from your spinning disk. And then these directories are for software. Ghost script wine, so the Windows 3.11 emulator in what is the year? So the year is May 1994. Boot disk using the standard Linux 1.0 release kernel. Let's look a bit at this timeline of SLS. Soft landing Linux system, Linux operating system distribution. So September 1992 uses Linux.94p4. So the Linux kernel versions go from 0. something, so 0.1, 0.0 to 0. etc. And then at some point they jump to 90 something. And then while at 90 something, there's many releases with the exact same version. So as in the case of .98, but they're P1, P2, P0, etc. So in order not to increase the version integers, Linus uses this P and then other integers. 96p4. Didn't use jump tables. Okay. And then immediately after, 1 month later, so the pace of releases, Linux kernel releases, and SLS releases is incredibly fast. October 1992, another release of SLS, Linux.98p0. That uses jump tables, whatever these things are. Okay. 3 days later, there's already text user interface installers. Text user interface system configuration. This text user interface compile my system from scratch, including the kernel. So sys build, sys install. They go to the next version of the Linux kernel, p.1, so in less than 3 days. A1 boot disk, A2 root disk. Image.taz. These are tarballs, so this is tar and archived using or compressed using, I'm not sure what this is. It might be uppercase Z or zip, I don't know. There's a /dev directory in 1992. There's PS. There's a /etc. There's a /usr/bin/telnet. There's a FTP client in /usr/bin. New disk. The common Lisp interpreter compiler. This is part of the tarballs that exist in the C4 directory. So in order to not have a million archives, tarballs in here in the top level directory, there are these subdirectories. So X10 is for TCL, X. I don't know what any of these things are. X9 is for TCL TK disks. So maybe a GUI front end for managing disks. TK mail, probably a mail client, or if not, at least a mail notifier, new mail notifier. So there's totally a window manager at this point. There's the x386 X server, TK News, probably a Usenet client, x386, x386 progs, so I know probably xterm and xcell and whatever. The other /usr/bin/x something executables that exist nowadays in a Linux operating system. But it was probably not using /usr/bin at that moment. It was probably using /usr/x11/bin. Okay, x7, what is it? Ghost script fonts. The file names are floppy disk friendly, so they use MS-DOS 6.22 limitation with normal file names, so that's 8.3, 8 characters for the file name without extension, and then a dot, and then 3 characters maximum for the extension. I know what any of these things are. Klondike, so a game like the Solitaire from Windows 95. TK, the GUI part of TCL-TK. Workman, this sounds like, I don't know, a system tray. XVDoc, I don't know. X for Picasso. X font, these are probably fonts packaged into multiple archives, so X font 3, X font 4, etc. So it's just all of the X fonts, all of the X bitmap fonts, and then split into multiple .tgz files, because you want all of these TGZ files to be to fit within 1.4 megabyte floppy, such that you can copy them around from a computer to another without using TCP/IP, without using networking, without using direct cable connection, serial connection, parallel connection. So just by using PC compatible style 1.4 small floppy disks. FVVM, the window manager, probably the best window manager in 1995. TCL, the non-GUI part of TCL-TK. I'm not sure what Xlink is. Wine and Ghost. So Wine is a very most important X11 application is Wine, because it resides in the X1 directory. The files in the X directories are not placed ascending by file name, but by importance. So x1 is more important than x2, which is more important than x3, etc. So Go script is the most important thing ever because I know you want to read PS files, PostScript files. Why the most important executable ever? Because you want to be able to run the Minesweeper from Windows 3.11, and then Xbase, which are X executables, and in here is probably Xterm or Xconsole or the X server. Okay, the most important directory is A2, 3, and 4. Let's see what's in here. Bin, so that's /bin /sbin /usr /bin, etc. Lilo, so in 1995 there already existed the bootloader that the Linux operating systems were still using in the year 2000, and the Slackware was still using in 2009. A TCP/IP user space stack. I'm not sure exactly what that could be. /etc/hosts. I don't know. No, /etc/hosts is in here in /etc. etc.tgz. System administration utilities that belong to /etc. The Linux loader. Boot multiple OSs from the hard drive. So this allowed you to have dual booting between MS-DOS with Windows 3.11 for workstations and SLS, the latest version 1.05. ps.procs. I'm not sure what this thing is. Maybe PS. The executable PS. sysmap. So this is the kernel sysmap, one of the two files of a kernel image. TCP/IP, probably, I know, ping and traceroute. Serial line. Okay, so this is about the serial port. And Vim. Wow, Brahms Vim is already available, and it's available in the most important directory, which is A2. And it's 76 kilobytes compiled with all of its features. Vim. Interestingly low numbers. Yes, it's tarball and then gzipped, but still 76 kilobyte for Vim with everything. Okay, and then A3. Additional binaries. /dev directory is pre-populated. There's no udev or devfs or something similar. That's the way it came. If you wanted to add more, I know, USB things, you needed to go into /dev and create directories there for your new hard disks or etc. Okay, another text editor, not Vim, but Joe, similar to WordStar. Text user interface text editor. System administration scripts, I know, maybe the script to add more users. User add or add user. Basic system files that belong in /bin /usr/bin and /usr/lib. More binary files. More serial port things. If you had two computers, the simplest way to communicate between those was to use a direct serial cable between those computers. All computers had serial ports and some also had parallel ports. So via the line, you could at least copy-paste files. So move files around without floppies. Copying files from your computer to the floppy and then getting the floppy to the other computer, copying back, which probably also involved splitting a ton of files into 1.44 megabyte parts, or maybe also compressing and writing and reading to a floppy disk was extremely slow and was extremely error prone. Like, you could write to a floppy disk and then not be able to read from the floppy disk. There were some bad blocks or something. You needed to rewrite to the floppy disk again and again until reading from the floppy was successful. So yes, concentrating on the parallel port was important. Okay, back to where we were. So a useless Lisp programmer environment was added to the C4 directory. Double compressed fonts. I'm not sure what that is. This was a release issue, like a release was made incorrectly with wrong permissions on files. Things like this happen. I'm not sure how, if these files were under version control, how many people actually did work on the SLS files that made it to the releases of SLS. Maybe just one person, or everything was done on one person's computer probably. Okay, serial port start at 0. /usr/include contains .h files, but in there there's /usr/src is the home of the source code release from the Linux kernel. CC no jump for now. There exists a TCP stack, but the kernel must be recompiled. So maybe in order to keep the kernel small, to be able to have a root boot floppy disk, some of the Linux modules were not part of the kernel, so you needed to recompile. There already existed text in the year 1992. There were no kernel modules in the year 1992. That's why you needed to recompile the kernel. There's a directory T with text, LaTeX. Emacs already existed in 1992 November. New versions of Mount make EFS. So ext2 already existed in November 1992. Lex and Yak. mtools, these are MS-DOS compatibility tools. So for changing the line terminator characters in plaintext files from \r/n, which is Windows end-of-line terminators, to Unix end-of-line terminators, which is just \n. UU decode. XDVI, which is probably a viewer for a graphical user interface viewer for DVI files. More text. F2C is, I don't know, Fortran to C or something. TCP/IP stuff in the sense of net/2 was moved from /etc to /etc/inet. I'm not sure what the I executables are. iDraw, iClass, interviews. I saw iCal. GoScript was already available. This is the GNU PostScript environment. So PostScript is a file format and program language, similar to PDF. And GoScript is an environment, so a compiler, fonts, language interpreter, etc. for PostScript. PostScript was the thing that you used if you were creating computer, graphics for books, for ads, for printing. There's shutdown already in /usr/bin. There's the Lilo, which is some of the executables from the Lilo package, which probably are writing to the MBR, to the master boot record, partition table. So at the start of the PC style hard disk, such that Lilo starts. So when you restart your computer, the first sectors of the spinning disk are being read. There's the MBR boot record there. It's being read. That reads the small part of Lilo, which is a bootloader, and then Lilo starts, shows text user interface, and allows you to select if you want to boot into SLS Linux or into MS-DOS Windows 3.11 for workstations. Xlock is a graphical user interface application, X application, which allows you to lock your session. Really important if you want to have work on your computer and want somebody else to not interfere with your day job. You just lock your monitor when you leave the computer. X11 fonts, 75 DPI fonts, MISC fonts for X, Emacs, GNU Emacs inside of the B2 directory, not inside the A directory. Emacs 98P4+, wow. Lilo the bootloader, version 5, /usr/src/lilo, so including the source code of Lilo is there. Manual pages. Man2 is probably, for the executables. What is? More I executables for X11. A1 is not a directory, but a floppy disk image. A1 is the boot disk image, and A2 is the root disk image, which contains, let's write this down. So November 1992, Linux 0.98p5. So the Linux kernel keeps releasing numbers which are really close to 100, but will not reach 100. 100 will actually be Linux 1.0, the first, between quotes, stable release. Sysinstall this is probably a text user interface application that allows you to install the system from many floppy disks to your hard disk. /image is a kernel image. Kernel images, you probably find them in /, so in the root directory on your spinning disk. Probably at the beginning it was /image, so not compressed, and then it went into /z image and /VM Linux, etc. And it includes the TCP/IP stack, so you don't need to recompile the Linux kernel just to have TCP/IP. There's top and free. Wow. Wow. So top already existed in November 1992. X11 was available since when? When can we prove that X11 was already available? In here, in 4th November 1992, we see iDraw iClass interviews, which, yeah, we also see XDVI in the 1st November 1992. So at least in October 1992, SLS already had the X11 server libraries, fonts, etc. Okay. There's a tar.gz for the source of the kernel. So LX, and then the version, and then the extension. iDraw. Says that TCP/IP stack, when it started working in the Linux kernel, at first only the loopback device worked more stabler. So connections to and from the 127.0.0 IPv4 address were more stable than getting out on the internet. So Ethernet not tested enough. Text user interface application SC, which is screen calc, a spreadsheet. Mail binary, this is probably a MTA, mail transfer agent. Add user command, this is a command line script, probably, bash script. Mirror system for SLS, so FTP sites that are serving these files and the parent directory. An entire release just because there's no link between /usr/src/linux to I don't know where. This directory contains the source code of the Linux kernel. If you install the TAZ file for the Linux kernel source, like this one, b4/lx98p5.taz. If you extract it, it will go into this directory. NFS client and server, December 1992. libc.so.4. What is this thing? Are the executables using shared libraries on Linux already in the year 1992. So some executables were not statically compiled in December 1992. This is what I read from here. So it says shlibs.exe, which stands for shared libraries. I can see libc.so.4, which smells like a userland, not kernel space C library, probably the GNU C library. Just add a hard link to FTP. And then immediately in December 1992, we start having shadow. So /etc/password passwd is using shadow instead of login. So you don't see passwords in plain text in /etc/passwd. You see just checksums of the passwords. And then shadow gets improved in the next months. Pretty complete TCP/IP networking stuff at long last. There's a shadow tarball, binary tarball. There's downstream Linux patches. So the SLS distribution is maintaining a list of kernel patches. You download the official Linux kernel source code archive tarballs, or you just take your Linux kernel source code from SLS, because it's part of the B4 directory, and then the downstream patches, which are not part of the Linux kernel but are part of SLS for the Linux kernel user kernel space, are either stored in a different .exe file like this one, lx patches, or are applied directly to the source code of the kernel. So either SLS provides vanilla Linux source code kernel tarball archive plus another archive with the downstream patches, or the downstream patches are pre-applied and then there's no vanilla Linux kernel source tarball from SLS, just the SLS specific Linux kernel tarball source code. Menus, this is text user interface, so ncurses or something similar, so executables or shell scripts that use menu or ECL or something similar, slang, ncurses, curses. So they display text user interface. The text user interface application looks like this. So it's a single page, you cannot scroll, and it refreshes every couple of seconds to show new content on the only page that's visible in your console, in your terminal. Sysinstall, the application to install from floppy disks to hard disk, existed from the start in SLS. So that means that the Linux kernel, the very first Linux kernel, 96 P4, already had something similar to ncurses, a terminal capabilities, library, etc. Maybe also menu, the executable that creates text user interface scripts. syslogd, the logging daemon, already existed in December 1992. secure mail, UUCP copy, UUCP Unix to Unix copy. This is part of Usenet, the server and client for the NNTP, and it's needed by Linus Torvalds in order to read and write from comp.os.minix newsgroups. ELM, I'm not sure what this thing is. I know, text editor. UUCP install and was removed a while back. Fonts for PostScript. News and mail. So mail means the SMTP protocol and news means the NNTP network transfer protocol, UUCP, whatever, or Usenet. Usenet is the precursor of Reddit and the, I know, Facebook, Twitter, social networking, YouTube, etc. Google directory, Google whatever, Google groups. Okay, Linux 99 appeared still in 1992. libc upgraded from 4. What was that to 4.2? So this is probably libc 4.0. This is libc 4.2. GNU screen. Wow, wow. New GCC. CPP, the C preprocessor. And then it switches from TAZ to gzip. So it still uses tar to create a tarball, but then that thing is compressed using the gzip algorithm, not Unix style Z. Or what is this thing? Probably uppercase Z. But the extension of the files is wrong. It's not TGZ, it's TPZ. I'm not sure why. The correct compression, so tarball plus gzip, but incorrect file extension TPZ instead of TGZ. Shadow is so important that it moved from B2 to A4 directory. More groups into Shadow. No need for /etc/PASSWD is now part of A4 shadow.tpz. And at the start of 1993, release of Linux kernel 0.99p4. A new directory, S1 for source files, for source tarballs. Proc PRs, magnetic type copy, MT. .99p4, the same kernel. libg++, so the beginning of the shared library for the C++ programming language. So that's GNU std lib C++, that thing. GCC, the std lib C++ version 2.3.3. Okay, all of the X was removed and replaced with the result of the open source project X386 release 1.2. Let's note this down because it's important. So February 1993, X 386. This is an open source project that was then forked to create x.org. The X server is monolithic, uses iMake, not GNU Make, and there's multiple executables for each type of video card. So one for VESA, XVESA, one for, what was there then. Each GPU had its own X executable. Shared libraries, GNU C library, glibc 4.3. The include files for GNU C library, version 4.3. But the shared libraries are not that important because they reside into B5 directory. So probably all of the files that exist in the A directories are not using the shared library, glibc. EFS2, so ext2 already existed in February 1993. The ext2 file system. Prior to ext2, the Linux operating system supported the Minix file system. So at this point, at least two file systems are supported, Minix and ext2, and probably if floppies are supported, then also FAT16, FAT32, VFAT, those things, for copying files from floppy disks. Zone info is the time zones, very important A4 directory. Kernel source code 99.99p6, and it comes pre-patched, so there's no more patches in another tarzip. The downstream Linux kernel patches from SLS are now part of the starball with the Linux kernel source code release. GDB, wow, there's already the GNU debugger in February 1993. Two days later, boot and root floppy disks for this new Linux kernel version 0.99p6. Updated the source code, the work on the installer, the sysmap file that's needed, along with the image.tgz. Okay, tpz, secure mail, the /proc directory probably, and ps executable that existed from the very start. Diff to compare two source code files is so important that it moved from B4 directory to B2 directory. More tags, more DVI. All of the file extensions changed from TPZ to TZ, and then from TZ to TGZ, which is the correct extension because it's using just tarball plus gzip. And now the number is extremely huge for the Linux kernel, 99p9. Downstream patches, source code, kernel image. There's a thing that's called sysvinit, which is an open source project, which is released somewhere, not part of the Linux kernel, not part of SLS. And SLS just takes the latest source code release from the sysvinit project, and it's version 2.4 at this point. Sysv in the sense that there's a /etc directory, and then there's run level directories in there, and then there's services which can be started at different run levels. There's a single user run level, a X11 run level, a multi-user run level, a reboot run level, a shutdown run level. Sysvinit is probably /bin/init/sbin/init and is started as PID1. Okay. Remove root from most groups. So the root user was part of most of the user groups in Linux. And now a huge revolution. Wow, this is a great one. May 1993, GNU Emacs is compiled with X11 enabled. So this Emacs is an open source project, provides an environment that's text user interface that can run in any terminal, that has a base library of features and an interpreter for a programming language that's called Emacs Lisp. And then you can, using these small building blocks and the interpreter, so the interpreter for the Emacs Lisp programming language plus this library with small Lisp exposed features, you can then create an entire world inside Emacs. So you can have, and you have GDB frontend for running the debugger, the kernel debugger, and the user space debugger. There's an Usenet client for reading and writing to Usenet groups. There's an email client for reading and writing email. There's a C programming language text editor. There's syntax highlighting. There's line numbers. You can run commands inside of Bash. You can fetch the results of the commands back into Emacs buffers. There's multi-windows. There's multiple files open at the same time, screen split, and a million of other features. There's source code in the S1 directory for sysvinit, for Getty, not for the Linux kernel. Linux kernel is more, the source code for the Linux kernel is way more important. It's not inside of the S1 directory, but it's inside the B4 directory, which B4 is probably the build directories. So A2 is what A directories are the ones used by most of the users. But then if you want to rebuild the system from scratch, the Linux kernel, etc., Lilo, and to be able to reboot, then you need the B directories from SLS. Xconfig, I guess it's a text user interface application which allows you to configure the X server. It asks questions like, is this a PC compatible computer? Yes. Does it support VESA? Does it support CGA? Does it support 17 colors? Is your keyboard German QWERTY or German AZERTY? Stuff like that. Swap fixes. I'm not sure what swap is. Maybe swap partitions can be created at this point in August 1993. Lilo bootloader NFS network file system, so you can read and write files to Solaris big Unix machines in your local area network. Again, if Ethernet works and TCP/IP works and non-local host networking works. 0.99p12 Linux kernel. ELF emulator. At this moment, only A.out file format is supported for executables and shared libraries and the kernel. And in order to run unmodified Unix 386 executables, so for instance, from a Solaris 386 installation, you take a statically linked executable as is, but that's using ELF file format. You copy it via a floppy disk to a SLS installation, and it will run because there's ELF emulator. I'm not sure how that works. Probably similar to the modern support for running non-x86 executables on Linux. So with bin FMT, you can run, for instance, ARM 32-bit executables or mono executables, .NET executables. Okay, the /etc/rc.net file or directory for net-2. We can see it in here. So again, the release for net/2 was June 1991, and it's mentioned in SLS net-2 in August 1993, and it's probably also mentioned above. Maybe many of the networking support text in here is about net/2 or source code from net/2. We can see it, for instance, in here. It says tcp/ip.taz. And we can see it in also other places. When it talks about Ethernet in here, tcp.taz. Okay, so we're at 99p12. Alpha kernel. Wow, there's an alpha kernel. And then the final kernel. So the 5 days before the Linux 0.99p12 kernel release, there was an SLS release with the 0.99p12 Linux kernel, but the alpha version. Go script. Shared libraries 4.4.2 GNU-C library, I'm going to guess. There's gzip, very important, A4. C1 is probably for compilers, so for GCC I'm going to guess. Include files for 4.4.2, which is the version of GCC probably. Their ncurses is mentioned at least in August 1993, but was probably available way before. Again, the bulk of SLS uses something similar to ncurses because the sysinstall executable that actually installs the operating system is using a text user interface mode, so it needs something, a library similar to ncurses. Which, if it's a C library, it's the first versions of sysinstall. Sysinstall are either a bash script that just calls the equivalent of the dialog executable, or is statically linked to the ncurses library. Something like that. Perl moved out of build into C3, but Perl is needed in order to build GCC. So I'm not sure why they did that. Bash is also needed in order to build GCC. CPIO. Smalltalk. I'm not sure what this thing is. Keymaps, keytables.tgz. More text, more text, more text. And then the big one. That's April 1994. Both SLS 1.05 released, but also probably the Linux kernel is compiled to use modules. Which is a big one, because you want the Linux kernel to be, the image to be as small as possible, the file that's in /image, but then to contain a number of kernel modules that are minimum minimorum needed in order to boot, like the ext2 driver and the FAT16 driver for the file systems, the Minix file system driver, the CGA, VGA drivers for monitors, the drivers for, I know, keyboards and serial ports, parallel ports, etc. But then a ton of modules, Linux kernel modules, or of Linux kernel source code should be built as modules, because maybe you're not always needing them, like, I know, GPU drivers for AGP, various PCI audio drivers, yes, ISA, and maybe a minimum of PCI needs to be built in, because otherwise the boot disk will just not be able to boot into your system that's installed on the hard disk, and keep installing the Linux kernel image that's on the boot disk without switching to the image that's stored on the spinning disk in /image. Okay, and we can see that. We can see similar text in here where it says that the Linux kernel can use kernel modules, but you need to patch it, in the sense that you need to configure it, build configure it. Maybe even if you used the Linux kernel configurations. So if you change the configuration and you build the Linux kernel, maybe not even then patches were enabled. Maybe patches was, maybe kernel modules were a feature that was work in progress, was still experimental and was not exposed, but then SLS was an early adopter and probably carried downstream patches such that this experimental feature of the Linux kernel, such that it supports kernel modules, was enabled by default in SLS 1.02 release from April 1994. Okay, there's the source code of the Linux kernel. Then there's source code for the Linux kernel that's related to networking. Then the binary kernel modules, or probably just the source code because it's in the b7 directory. TK-man is probably a graphical user interface application for showing man pages. So whatever you do with the man executable at the command line, you can probably do with TK-man with the graphical user interface. I have never used that thing and curious if I have it installed. I have man installed. And seems to not be available anymore. So this is an open source project that probably disappeared. TK-man. Okay, so there's work related to Linux kernel modules in April and on the 1st of May 1994. It says Linux kernel -net directory, the Linux kernel only the net directory, and the downstream patches which enable Linux kernel modules. And then SLS, the Linux distribution, disappears. Probably this is the last release. 1st May 1994, SLS 1.0.5. At least this is what's available in the slackware.uk mirror for SLS. Okay, so a ton of very advanced features happening in the very early days of the Linux kernel. Linux kernel modules. I'm not sure when the FreeBSD project added kernel modules. Shared libraries, so a C library and not building all of the executables statically linked. The ext file system in 1993. The X-Free project 1993 is also available in FreeBSD 1.0 release. GNU Emacs compiled with X11. Wow. Wow. I'm not even sure what toolkit it used because GTK was not available at that time in 1993. So at this moment, you are able to install a Linux operating system on your PC computer. It's the year 1994, so probably your computer is a 486DX, the fastest possible. Or maybe even the first Pentiums did appear at that point. So we have a Linux PC, power personal computer, IBM style compatible. You have a keyboard, a mouse. Hopefully the mouse is Microsoft style with 3 buttons and no scroll wheel. And it's using the parallel port. No, it's using the serial port, not the PS/2, right? And you can boot from the Linux operating system from boot disks. You can install it on your IDE spinning disk. It uses the MBR partition table. There's Lilo, the bootloader. There's ex2 file system, which is great. Compared to Minix, it's high performance. It needs fscheck from time to time. Whenever you reboot a computer, the fscheck might start or not to check all of your file systems or of your partitions which are of type ext2. And if you shut down your computer by plugging off the power supply, that's not a great thing. If you have a power outage, that's not a great thing. When you restart your computer, make sure you're running fscheck. That was running automatically because the clean shutdown bit was not set. Sometimes you lost a bit of files, sometimes not. And then you're using the xconfigure application. You're using the sysinstall application from SLS to install your operating system to the hard disk. You're using the xconfig application to configure the X11 that starts correctly, has the correct resolution, the correct refresh rate, hopefully. If not, you're fiddling. You're installing all of the software possible from all of the directories of SLS. You're getting the possibility of rebuilding the Lilo, Linux kernel modules, and other things from scratch. You have a full compiler suite. There's GCC, I'm not sure what version available there. There's a GNU-C library, G++, C++ library, C Lisp, C preprocessor. There's certainly the GNU assembler, GNU make. There's probably also the auto tools. There's Bash, so you can create Bash scripts. There's X11 applications, XVVM, the window manager. There's Xman for the TKman for looking at Unix manuals in graphical user interface mode. There's graphical user interface terminals, Xterm. There's Xviewers for DVI and Ghost script files. No web browser. No HTTP yet.